Hello everybody, we're going to talk about right triangle trigonometry now that we've had a chance of getting some basic definitions involving angles in radians and degrees. We need to be able to handle the trigonometric ratios of right triangles that contain those angles for any angle. Now it turns out that right triangle business is very important when it comes to mathematics because everything that we do involving trigonometric functions involves ratios of sides to triangles, and that's a very important idea based on the concept of similar triangles. That is, if I had a triangle, let's say, that was similar to this angle 2, 3, right? The ratio 2 to 3 would be the same whether I had a triangle that was 10 times as large as it was if it were 10 times as small, as long as it contained this same angle theta right here for these angles, for these sides 2 and 3. So we define our trigonometric ratios, which I'm sure you're probably aware of most of anyways. Most people remember sine of the angle theta being the ratio of the opposite side to the hypotenuse side of the right triangle. Cosine, when we say, by the way, opposite, I should point out that that opposite means it's opposite of the angle, right? Adjacent means next to the angle, and hypotenuse, of course, is the longest side of any right triangle. So cosine is the adjacent over hypotenuse. Tangent of the angle is opposite over adjacent. There's three other ratios that we need to know as well. They are the cosecant of the angle theta, which is the reciprocal of our sine function, hypotenuse over opposite. Secant of theta, which is the inverse of our cosine function, that's hypotenuse over adjacent. And cotangent of the angle theta, which is the adjacent over the opposite. Right? Now, we don't even really have to know the angle as long as we know two sides of a right triangle, because if we do have a right triangle, we can simply just apply the Pythagorean Theorem to help us find the rest of the information that we're interested in knowing. For example, in this particular case, we have a triangle that has an adjacent side of 3 and an opposite side of 2 from our given angle theta. So what we're going to do is we're going to say, well, by the Pythagorean Theorem, if we take the square of one side, add it to the square of the other side, we're going to get the square of the hypotenuse side. Well, in this case, that's 4 and 9, which is to say 13. But don't forget, we're taking the square, since our hypotenuse is always considered as a positive value. Our hypotenuse itself is the square root of 13. So if I'm writing these out, I say, well, all right, what would be the sine of the angle theta? Well, then by this definition, by the way, sine of the angle theta without the angle theta is just a sin. Don't do it. Make sure you put the angle after it, right? Sine always has to be of an angle. So sine of the angle theta is our opposite over hypotenuse, so we would write 2 divided by the square root of 13, but we'll take the common practice of rationalizing the denominator right here. So we actually should write 2 radical 13 over 13. Similarly, if we take our cosine of our angle theta, we're going to take the adjacent side, which is 3 in this case, over our hypotenuse, so 3 over the square root of 13. That's going to simplify when we rationalize the denominator as 3 times the square root of 13 divided by 13. And finally, if I take the tangent of my given angle theta, in this case, opposite over adjacent is going to give me 2/3. Now, those are the three basic ones that most people remember. The other ones that we have to know here, cosecant of the angle theta defined as hypotenuse over opposite. So we take our hypotenuse over opposite this time, and we get square root of 13 divided by 2. If we take the secant of the angle theta, well, it is the reciprocal, hypotenuse over adjacent, so we're going to take square root of 13, divide that by 3. And if I'm looking for my cotangent of the angle theta, we're going to treat that as adjacent over opposite. The adjacent side is 3, the opposite side is 2, so we'd say 3/2. We're going to leave them in this exact value form rather than worrying about the decimal form, unless we actually need to know that decimal form This is fine. This is exactly what we want. So we're done.